in the middle of this question, this is on page. We'll do a little recap of it as well. On page 109, we had done A, and we were on B, and we're going through the steps again. So again, you list your non-permissible values, determine whether they're going to be vertical asymptotes or holes, and it's only going to be a hole if a non-permissible value simplifies and goes away. Then the degree was bigger in your denominator. Anytime your degree is bigger in your denominator, you're going to have a horizontal asymptote at y equals 0. So the start off is finding your vertical asymptotes through your non-permissible values, then your horizontal asymptotes. We found our intercepts, and at this point we have this. And I've talked about how the vertical asymptotes separate your graph into 3 sections. There would be this section here, section 1. There'd be the section in between the two, that would be section 2. And then there's the section after, would be section 3. And right now, with our intercepts, we had 2 points. And so we'd be able to say, I know these 2 points are going to connect. I know that it goes down towards an asymptote. But now I have a problem because, and I'm going to draw it on here, first of all, in purple. I have nothing in section 1. I still need to graph something in section 1, but I don't know what it looks like in section 1. In section 2, I was able to graph this part, but I'm on the x-intercept. The question is, should I go up towards the asymptote or down towards the asymptote? I don't know. And I have nothing in section 3. So whenever there's something that you don't know, in our steps, which I shrunk down really small here, in step 4 it says, find your intercepts and nice points. You need at least 1 point in each section, sometimes more. And this is an example where we need more points in order to determine what this graph is going to look like. So in this green box is our equation in factored form. I'm going to find a point in section 1. If I want to find a point in section 1, I would probably say, okay, I need to plug in something less than -7. I'm going to find out what happens if I plug in -8. Well, up on the top here, just do each of these factors on their own. If I plug in -8, that'll be -6. This will be -1. This will be -9. And all of those points together will give me -6 over +9, which would reduce to -2/3. So I go onto my graph, I go to -8, I go to -2/3, I label that point, and now in section 1, I have enough that it has to go down towards this asymptote and towards my horizontal asymptote. It cannot go through my x-axis again because I already found all the x-intercepts. So one of the reasons we find our x-intercepts is to show that we can't have any more. So once I have that single point in section 1, I just need to draw towards the asymptote, and I'm fine. Next, I'll erase this. In section 2, I technically didn't have enough to decide what happens on the other side of -2. Does it bounce off that x-intercept, which could be a possibility, or does it go straight through? I don't know. So I'm going to find another point in this section. And I could plug in anything to the left of -2 up to -7. So I'm going to try -6. Sometimes it's nice to try something close to your asymptote. So if I plugged in -6 on the top, I would get -4. -6 plus 7, that would be 1. And -6 minus 1 would be -7. And -4 over -7 becomes 4/7. So I label that on my graph. -6, 4/7. And now, because that point is above, I would know my graph goes up towards my asymptote. And finally, in section 3, I need to pick a point in section 3. Since x is 1, I'd probably choose 2, 1 to the right. 2 plus 2 would be 4 on the top. 2 plus 7 is 9. 2 minus 1 is 1. And I get 4/9. Go to my graph. And because that is in the upper section, I can draw it towards the asymptotes. And I have my final graph. Questions for practice on this one? 5, 6, and 7. So I was just finishing up from yesterday. We are basically done this unit. We are just need to practice these steps in a bunch of different situations, because as you saw in part A, this graph in part A looks extremely different than this graph in part B. So how and what kind of different situations come up in these steps, right? This one, we had to do 3 nice points. Sometimes your x-intercepts and y-intercepts are enough. Like in the last example, you didn't have to find any extra points other than your x-intercepts and your y-intercepts. So it all depends on what your graph is looking like. And if you're unsure of something, you have to try another point. So in this last example, we had nothing in section 1. So we had to find a point. And then once I found this 8, -8, -2/3, well, then I could draw it towards the asymptotes. In section 2, I had 2 points, but they actually weren't helpful enough to complete it. I had to find another point to complete that section. So let's go to example 3. We're going to take our steps. And paste them over there, small, again. And again, for each of these graphs, they ask you to look at certain things, like what are the non-permissible values, what are the asymptotes, what's the domain and range. But we are going to actually go through the steps of graphing it completely, because that's what's going to be asked of you all the way through, so we can see what you've done. So as always, when we start, our very first thing we do when we start is we factor completely. The bottom here is the difference of squares. So that's x plus 2 and x minus 2. Once you've factored, you can list your non-permissible values. In this case, if x is either -2 or 2, you'd be dividing by 0. And so your non-permissible values are always where you're dividing by 0. And now we have to determine, are those non-permissible values going to be holes in our graph, or are they going to be vertical asymptotes? Since neither of them cancel out, they will both be vertical asymptotes. Next, we have to determine horizontal asymptotes or oblique asymptotes. When the degree is bigger in this situation in your denominator, this I think is the easiest one. when the degree is bigger in your denominator, you will always have a horizontal asymptote at y equals 0. So at this point, I usually start graphing. And I have a vertical asymptote and label it at x equals 2, another one, and label it at x equals -2, and my horizontal asymptote, label it at y equals 0. So I can already see in this graph, I have 3 sections. Probably I'll need some nice points, but we'll find out. Next, always find our x-intercepts and y-intercepts. Y-intercept is always the easiest to find. I like to go to my original equation, because if I plug in 0 for x, I get -4 over -4, which is +1. So I know that I'm going to have this point 0, 1. Next, my x-intercepts, that's where you plug in 0 for y. And in your original equation, and we've talked about this in our other examples, you could solve this by getting rid of your fraction first, multiplying both sides by x plus 2 and x minus 2. That would get rid of the bottom on the right-hand side, and when you multiply the left, which is 0 by anything, it's going to stay 0. So usually we don't show that step and just say, well, I know that if a fraction is equal to 0, my numerator has to be equal to 0. And looking at my numerator, which is just a single factor, the only place that's going to equal 0 is when x is 4. So I know my x-intercept is 4, 0. So this graph has 3 sections. It has section 1. It is this section in between section 2 and this section 3 over here. And we have to determine if we have enough points in each section to draw. Section 1, I have no points. So I'm going to have to find a nice point in that. Section 2, I have a point. Do I have enough information to draw in section 2? I do. How do I know? Well, it can't go down towards the asymptote, because that would make a new x-intercept. And I already algebraically found all of my x-intercepts, and there's only one. So the only possibility in section 2 is that it has to go up towards my asymptote. So I could draw section 2. I don't need any more points in section 2. Section 3, I have a point. The problem is it's on the x-intercept. So it's possible that it could go up towards the asymptote or down towards the asymptote. And I don't know, does it bounce off of here? Does it go up? What happens afterwards? So we are going to need some nice points. First of all, in section 1, I would plug in -3. So I'll go to my factored form. If I plug in -3, get -7. -3 plus 2 is -1. -3 minus 2 is -5. This would be -7 on the top and +5 on the bottom, which gives me -7/5. So I label that point -3, -7/5. And now I have enough in this section to say that it has to go down towards that asymptote and towards the asymptote of 0. Section 2 is good. Section 3, I have a couple of problems. I don't know whether it goes up or down towards my asymptote. And by the way, I call these nice points, but like, normally we'd be like, -7/5, I don't know. We're pretty We don't like fractions very much sometimes when we're graphing, but it's still considered a nice point. And this one, does it go up or does it go down? I would have to plug in negative 3.5. That doesn't seem nice at all. So let's see what happens. Or not, sorry, not negative 3.5, positive 3.5. Can you see that that chooses a point somewhere, I needed a point somewhere in between positive 3 and positive 4. I'm totally off. Between 2 and 4. It's Monday, isn't it? Can you, I mean 3.5 would work, but now that I think about it, isn't 3 a lot nicer? Yes, let's choose 3. Somehow, I don't know, I think it's because I labeled it section 3. I think my brain made the asymptote at section 3. Does your brain do this to you sometimes when you're doing that? It's like you see one number and then all of a sudden your brain like gets influenced by that number and then you start writing the wrong numbers down. That is very normal. In fact, I think that's one of the things that math and pre-calculus wants you to realize is that you are very influenced by little things around you which can throw you off. And there's certain jobs where they don't want people to be thrown off, right? You don't want your airplane pilot who's getting near to the ground to be all of a sudden distracted by something else. There's certain times that you want extra focus. So I think that's one of the reasons why math is so needed for a bunch of things, because it does teach you that ability to focus. So I'm going to plug in 3. And when I plug in 3, this is another problem. 4 should be at 4, and I think I labeled it at 3. Also causes a problem for me. But when we plug in 3, all right, so plugging in 3, we would get in the top of our fraction a negative 1. 3 plus 2 is 5. 3 minus 2 is 1. This will end up being negative 1/5. So as far as where that is on my graph, 3 comma negative 1/5. That's below the x-axis. Well, that would tell me connected those 2 points, it has to go down towards my asymptote. Now remember that horizontal asymptotes tell you what's happening at extremes, extremely large values of x and extremely large negative values of x. It is possible, and we see right here, that we have an x-intercept, which is right on the asymptote. It's only vertical asymptotes, because they represent non-permissible values, that your graph can't go through. But your graph sometimes goes through horizontal asymptotes. So we have another issue here, because this is the only x-intercept. What happens here? Does it go up and come back down? Does it bounce and then go back up? We don't know. So we're going to have to find another nice point. I'll plug in 5. See what happens when we plug in 5. Well, the top will be 1. 5 plus 2 is 7. 5 minus 2 is 3. We get 1 over 21, which is really close to 0, but it's a little bit above, which tells me my graph goes up and then will come back down towards my asymptote eventually. So what makes these graphs a little bit tricky is after you've done the steps, you sometimes don't still have enough information to complete the graph. So you have to go back to, like, your nice points is basically your very beginning table of values way of figuring things out. You figured out some of the characteristics, but you need more points to see other characteristics. All right, part B on question 3 was x squared minus 4 over x squared minus 9. So x squared minus 4, that factors nicely to x plus 2, x minus 2, and x squared minus 9, another difference of squares, factors nicely to x plus 3, x minus 3. Again, non-permissible values is just where you're dividing by 0. So x can't equal negative 3, and x can't equal positive 3. And now we have to determine, are those going to be wholes, or are they going to be vertical asymptotes? Again, you would have a hole if a non-permissible value cancels and goes away. In this case, those non-permissible values stay. So we would have a vertical asymptote at x equals negative 3 and x equals 3. Then for horizontal or oblique asymptotes, we have the situation where we have the same degree on the top in your numerator as in your denominator. That was group 2. Group 2, when it's the same in your numerator and your denominator, will always be a horizontal asymptote, and it'll always be a horizontal asymptote of the coefficients of the highest power. So originally this was x squared minus 4 over x squared minus 9. Your highest power is an x squared there and an x squared there. 1 x squared over 1 x squared, 1 divided by 1 is 1. That will be your horizontal asymptote. So again, at this point, I would start drawing in my asymptote. So I know I'm going to have an asymptote at x equals negative 3, and an asymptote at x equals 3. Also a horizontal asymptote at y equals 1. So first thing I notice is I have 3 sections because of my vertical asymptotes. I'm going to find my y-intercept first, because that's super easy. If you plug in 0 for x, I would go to the one where I have the highlighting there. I just have negative 4 over negative 9, which is 4/9. Should give me 0, 4/9. X-intercepts, if I plug in 0 for y. Again, in a fraction, when you're trying to find out where it's equal to 0, you just have to look in your numerator. What would make your numerator equal to 0? And that's where the factored version is nice. You can see that it's equal to 0 at negative 2. And at positive 2. So I'll label those points on my graph. And then I'll check my section. Section 1, I have no points. So I'm definitely going to have to find a point there. Section 2, in between. Well, section 2, we can join these points, and it has to go down. And one of the things that you can think about with your x-intercepts that kind of connects to our first unit is multiplicity. Right? Someone might ask, well, why doesn't it bounce off there and go up? Well, if you have a bounce, then that x-intercept would show up more than once. It would have to have a squared for that bounce to be there. These ones all have a multiplicity of 1, so they should go straight through. So that's why we have enough information in section 2 to draw the graph. And finally, we have no points here in section 3. So I'm going to find a point in section 1. I would probably choose negative 4. And I guess, depending on what you'd like to do, the original equation for plugging in -4, I think, is even easier than the factored one. Can you see that if you plug in -4, that this would be positive 16 minus 4 would be 12, and positive 16 minus 9 would be 7. And so I would have the point -4, comma, 12 sevenths. Where is that? 12 over 7 is bigger than 1, so that is in this section. And that's enough in this section to go above. And the nice thing about using the original here is, can you see that plugging in +4 will give you the same result as plugging in -4, because of x is squared. So I'm going to also have +4, comma, 12 sevenths, and that'll figure out section 3. So as far as our nice points go, sometimes your graph feels like you can graph it quicker, and sometimes it takes longer. The steps, though, stay the same all the way through for each of these. So I'm going to get you to circle questions 9 and 10.